Okay, this video is for my pre-calculus students for Law of Sines Cosines Lab 2. I've already made 2 videos previously for the first 6 problems. I think there was 3 problems on each. So this is number 7. 3 streets intersect in pairs enclosing a small park. 2 of the angles at which the streets intersect measure 85 degrees and 65 degrees. The length of the longest side of the park is 275 feet. Find the lengths of the other 2 sides of the park. So this is a triangular park because there's 3 streets. Whoops, because there's 3 streets they're talking about. So let's kind of draw a picture. Part of the thing is drawing the picture. So 3 streets are intersecting, enclosing a small park. So here's my park. 2 of the angles of which the streets intersect are 85 degrees and 65 degrees. So let's make this angle here 85 because it kind of looks like that. And let's call this one 65. Okay, because sometimes the picture goes with it, but you can try the best you can. But you want to make sure that you just label everything. And then they said the longest side of the park, okay, is 275 feet. So what are the other 2 sides of the park? So this is 275 feet because this looks like the longest side. And what I do here is they want us to find the other 2 sides. So I always tell everybody, if you're not for sure how to get started, label your angles ABC and then look at what you have. And I see here that I have a side opposite an angle, so I know I can use the law of sines. And I have another angle here, and actually I could find this third angle if I wanted to. If I add those up and subtract from 180, I get 30 degrees. So that's cool. See, I don't want you to forget that you know all that stuff before you get started. So you actually can find it using the law of sines for both sides. So the first one I'm going to do is, because they gave us this, 275 is to the sine of 85 degrees. And let's pick one we want to do. Let's do the one across from this. So we're going to do little a. So as a is to the sine of 65 degrees. It doesn't matter which one you start with. That's just the one I picked. And then we're going to cross multiply. So I have a times the sine of 85 degrees equals 275 sine 65 degrees. Then divide by that. So side A is going to be 275 sine 65 degrees divided by sine of 85 degrees. Okay, and it didn't really tell you as I paused there. I was looking to see if they told you how to round, but they didn't. But since this is in whole numbers, we're going to round that to a whole number. If you put that in your calculator, you get 250 feet rounded. So this is 250 feet. So now I know this is 250 feet. Okay, so we found the first one. Now I want to find the other side. So what I usually do is I use what they gave us. So I'm going to use that again, and then I'm going to find little c is basically what I'm looking for now. So I'm going to do 275 is to the sine of 85. I'm going to use that again because they gave that to us, so that's accurate information, as little c is to the sine of 30. Now we do know the sine of 30 is a half. And that may or may not help you, but you can cross multiply and do everything we did. So if I solve for c, I'm skipping a step here because I'm running out of room. It's going to be 275 times the sine of 30 degrees all over the sine of 85 degrees. And when I put that in my calculator and round it, I get 138 feet. So this is 138 feet. So there we found the other 2 sides. So the beginning of this lab, if you'll notice the first 2 videos are predominantly the law of cosines. This one, I use the law of sines twice. So it's just depending on whatever information they gave you, and I like using that part. So there's number 7. So number 8, let's look at 8. On the playground, the 10-foot ladder to the top of the slide makes an angle of 48 degrees with the ground. Okay, so let's draw that. So I have this ladder on the top of a slide. So here's my slide. Okay, and they said it makes, whoops, good picture. Let's just erase this a little bit. There we go. And they said it makes an angle of 48 degrees with the ground. Is that right? The slide makes an angle. Oh, no, it says the slide makes an angle of 48 degrees. So this comes over here. Oh, I almost put it in the wrong spot. So the slide makes an angle of 48 degrees with the ground. wait a minute. 10-foot ladder to the top, which makes an angle of 32. And, oh, the ladder makes it 48. Okay, so I'm sorry. Wait a minute. Let's erase this. Let's try this again. Let me read this again. Because sometimes on the playground, the 10-foot ladder, so I know this is 10 foot. So let's do this. 10-foot ladder right here. Okay. Makes an angle of 48 degrees with the ground. Okay, there we go. Sorry. I was like reading ahead. And the slide, so this is my slide, makes an angle of 32 degrees. There we go. I apologize for that. Sometimes I get reading ahead. So there's our picture. How long is the slide? So they basically want us to know how long the slide is. So I'm going to first label these A, B, C, because that helps. So I'm really looking for little a for the slide. And I look at what I have, and I see I have these two angles here, and I'm like, oh, yay, I know this angle up here is 100 degrees. I don't know if this will come in handy, but I do have one side. I do have this side opposite this angle, so that means I can use the law of sines. So let's do this. I've got 10 feet is to the sine of 32 degrees equals, so there's that. Let's find the slide is A. That's my slide. It's the sine of 48 degrees. There we go. Now we can cross multiply. So I have A, when I cross multiply, is 10 times the sine of 48 degrees divided by the sine of 32 degrees. Now, if this bothers you, like I've said before, just make sure you show the step in between as you're cross multiplying. So when I put this in here, and they said, how long is the slide to the nearest tenth? So I always have to look. So the slide actually comes out even because when you round it, it comes out to be 14.0 feet. So this is my slide, 14.0 feet. I just found that. Okay, so that's good. We found the slide. Now, what do they want me to do? So this is A. What do they want me to do for B? What is the distance from the foot of the ladder to the foot of the slide? So they're basically wanting to know little b. So I'm going to do B because this is the ground. So again, I was given the 10 feet and the 32, so I'm going to use that for B. 10 is to the sine of 32, and now I'm looking for the length on the ground. So that's going to be little b is to the sine of 100. And see, by me filling in that angle, I'm like, yeah, I've got enough information to do this. So I'm going to cross multiply. So b is going to equal 10 times the sine of 100 degrees divided by the sine of 32 degrees. And I skipped a step again just to tell you that. So B comes out to be to the nearest tenth, because that's what they asked us to do again. Nearest tenth comes out to be 18.6 feet on the ground. Okay, so we just did number 8. Now let's see if I can get 9 in here. So the distress signal from ship S. So ship S is here. This has a picture, so that's nice. Is received by 2 Coast Guard stations located 3.8 miles apart. So right here, they told us this was 3.8 miles from the 2 Coast Guard stations, because this is on the ground here, or the, I guess, land. From station A, the signal makes an angle of 48 degrees, so they put that in for us. How nice. And with the coastline. And from station B, the signal makes 67 degrees with the coastline. Find to the nearest tenth of a mile the distance from the ship to the near station. So if you look at this, you're like, which one's the nearest station? Well, let's look at these angles. First of all, I added these up and subtracted from 180 because you just never know what you're going to need. So the angle here is 65. And I looked at it. The nearer station, okay, has to be with the smallest side. So look at the angles. This is the smallest angle. So the side opposite is going to be, the smallest angle is going to be the shortest side. All right. So I'm looking for little a here, okay, because that's A. 67 is the largest angle, so that's going to be the longest side, and the 65 is across from the middle, if you will. So you need to know that information, because how would you know unless you did them all? And I did have a student say, Mrs. Pond, I just do them all and see, but that you don't, it's not necessary. So I'm going to do A is to the sine of 48 degrees and the one they gave us was the 3.8 is to the sine of 65 degrees. Oh, this one's a quickie because it's just the law of sines once. And so I'm going to cross multiply. So I have 3.8 sine of 48 degrees equals A times the sine of 65 degrees. And then I'm going to divide by the sine of 65. So I get A to be, A is 3.8 sine of 48 degrees, all divided by the sine of 65. And you'll see I showed that middle step because I have room, because lots of times I think I give enough room. And they wanted us to do this to the nearest tenth of a mile, so I did 3.1 miles. So that is going to be the closest. Now, if that bothers you, that you're not for sure if that's the shortest one, go ahead and do the other one if you want. But I just showed you why this one's going to work, because it's across from the smallest angle. So I hope this helps you. I'll do one more video.